All right, so as always, let's define what an exponent or an exponential expression is. Then we're going to learn a few rules that apply to these exponential expressions. There's about 6 or 7 of them. We're going to learn all of them today. And we're going to see how to simplify somehow complex exponential expressions with multiple variables, different powers, maybe fractions, parentheses, powers over the parentheses. We're going to see different cases, and we'll see all the rules that we need to simplify those. So let's define first what an algebraic or an exponential expression is. So when you have an expression like this, a number a to a power b equals some value, let's say c. Okay, so this is what we call an exponential expression, simply because it has a, let's actually use different letters, maybe b for base and p for power. And here there's some value, v. Okay, so this is what we call an exponential expression. Basically, b is the base of that exponential expression, and p is the power. And of course, this is the value. V is the value of that expression. When you evaluate it, you get some value or some number. Okay, so that's what makes an exponential. It's an exponential expression. Okay, this is what makes an exponential expression. Could be one variable, or could be more, could be different powers. We call that an exponential expression. As an example, something we're all familiar with, maybe 3 to the second. You can see 3 here is the base, 2 is the power. So to find the value of this or to evaluate it, we have to break it down first. We have to expand it and then multiply to find the value. So what is 3 to the second? We expand it, it will be 3 times
9.
3 times 3, right? So you take the base and you repeat it as many times as the power with a multiplication in between. So you get your value 9. So this is exponential form or exponent form. This one here is expanded because we break it down, we turn that into a multiplication. We call that expanded. Of course, once you expand it, when you multiply, you get the value of that exponential expression. So that's a simple one. It could be, the power could be much higher than this. Could be a negative number, could be a fraction, it could be basically any real number. It could even be a decimal, any real number, meaning decimals, integers, whole numbers, rational, irrational, everything. So that's basically how exponential expressions work. Let's take a look at another example, maybe with higher power. So when you see this, so we say 2 to the 5th, 2 raised to the 5th power. Let me write that better. To raise to the 5th power. It's basically how we read exponential expressions. 2 raised to the 5th power, or you can simply say 2 to the 5th for short, or you say here 3 to the 2nd, maybe 4 to the 7th, and so on. So again, this is the exponential form, okay? And we need to turn this to evaluate it without a calculator. We're gonna expand this into a multiplication. So what is 2 to the 5th in expanded form as a multiplication?
2
2
times
times
2
5
times
times 2 times 5. Do it 5
times 2.
times.
2 times itself 5 times, right? 2 the base. One, two, three, four, five. So you take the base and you repeat it as many times as the power with multiplications in between. And then you just evaluate 2 at a time. Don't try to multiply the whole thing at once. Just do the first 2, for example, here. This is 4 times these 2 also turn into 4, and then times 2. Then you repeat again, do 2 at a time only. Do not try to do the whole thing at once. I see a lot of people get it wrong. Now we're going to times these 2 together. That's 16 times these 2, and that's 32. So 2 to the 5th is just a number, a real number. It's just basically 32. They're written in 2 different formats, the exponential form, and this is the actual value, and this is the expanded form. So that's basically how you evaluate exponential expressions, especially when the power is a whole number, like this, a whole number, or a natural number, could be 1, 2, 3, 4. If it's different than this, if it's a fraction or if it's a decimal, if it's a negative number, there's different ways to deal with this. We're going to see all those cases as we go. So for now, that's basically a definition or an introduction to exponential expressions. Now let's see what happens when you have, let's say you have a negative power, or before that maybe a fraction. So let's say 2 over 5 to the 3rd power. Always identify your base first, then identify the power. What is the base and what's the power in this expression?
2 over 5 is the base.
That's right. And 3?
And then the
Is
3
the
is
power.
the
The power.
The power. Okay, so same way as we did. So we're going to multiply the base by itself 3 times. So 2 over 5, we're going to repeat that 3 times. And once we expand it, we just multiply. So 2 times 2 is 4, times 2 is 8. And here, times these 2 first, 5 times 5. That's 25 times 5 would be 125. Okay, that's basically how you evaluate that. There's a second method to this. The other method is, instead of repeating this 3 times, we can actually break it down. We can write 2 to the 3rd and also 5 to the 3rd. Each one, the numerator and the denominator, each one to the 3rd power, because the parentheses here mean that these 2 share the same power. So you can break that down into 2 different exponential expressions and then evaluate each one on its own. So you can say 2 to the 3rd is 2 times 2 times 2, that's 8. Then you expand this one, 5 times 5 times 5 is 125. So a couple ways you can do this. Either way, you get the same result. But make sure you have parentheses. If you don't have parentheses, that means the 3 belongs to 2 only. If you don't have these parentheses. But since we have them, that means 3 belongs to both of these. So when we expand them, or when we break them down into 2 exponential expressions, each one of them gets that power. Here's an example of that. Let's say you have 3 to the 2nd over, let's say 4 or 7. So what do you think this is equal to? What's the base and what's the power? So, or in other words, the power 2 belongs to which number?
3.
3.
That's right, only belongs to 3, not to the 7, because we don't have the parentheses. So we can evaluate this, so that's 9. And this 7 doesn't get that power because we don't have parentheses, it stays the same. Okay, 9 and 7, try to simplify it if possible. If not, just leave it like that. Another one with, let's say, Now let's see what happens when you have a negative power. So as I said before, so p here and also the base are real numbers. That means they could be anything. They could be negative, they could be positive, could be fraction, okay? They could be decimals. It could be a bunch of things. Because real numbers, this is what they are. Basically any type of number, not including the complex numbers. So let's see what happens if you have a negative number here. This whole time the power was positive, as we saw, but let's see what happens if you have a negative power. So let's call this, I don't know, negative powers. Negative exponents or powers. By the way, we say exponent or we say power. Basically, we mean the same thing. Okay, so this number here, the power is 2, or we say the exponent is 2. Let's say we have 3 to the power negative 2. That's possible. Again, the power can be negative. What do you think 3 to the power negative 2 is? Before you say negative 9, it's not negative 9. What is 3 to the
It's
power
positive 9.
If you say it's positive 9, then this would also be positive 9. But they don't look the same. So what's 3 to the power negative 2? This is 9. We know this is 9 for a fact. It's 3 times 3 is 9. But this can be the same as this. This one has a negative. This one has a positive. Again, it's not negative 9. So what do you think we do in order to find that value? Does anybody know what the value is? Okay, so these are two separate problems or examples. So here's what you do when you have a negative power. First, you want to turn that into a fraction if it's not already a fraction. Just put 1 under the number. And then what you want to do is we want to make this power positive. So we're just going to move it down to the other side of the fraction, and that power will turn positive. And basically, and this one, we're going to move this one up. It's like flipping it, or most importantly, we're trying to move the negative power to the other side of the fraction. That turns into 3 plus to the power positive 2. Okay, and 1. Okay, all you have to do is move the negative power to the other side. It turns into a positive. Now we can say 1 over 3 to the second we know is 9. Okay, so that's
Professor, can you try that with another number, please?
Yeah, okay. So
thank you.
Again, we have 3 to the power negative 2. So whenever you have a negative power, all you have to do is move it to the other side and it turns positive. So 1, in other words, instead of saying 3 to the power 3 to the power negative 2, you're thinking about 9. So instead of saying 9, just say 1 over 9. You don't have to go through the middle step. Here's another example. So if you have 5 to the negative 2, it's not 25, but it will be just like here. So instead of
1 over 25.
1 over 25. So whenever you have a negative power, ignore this for a moment. Think of it as a positive. You would say 3 to the second, which is 9. But since we have this negative, we flip it. Instead of saying 9, we say 1 over 9 for this reason. Same thing here. So we're going to say 1 over 25. So it's not 25, it's 1 over 25 before the negative.
So when it's a negative exponent, it automatically becomes a fraction?
It could already be a fraction. If not, we make it a fraction, yes. So one more example here. Let's say 6 to the power negative 2 would be
1 over 36.
That's right, 1 over 36.
36.
So you can skip these 2 steps here. Instead of moving it first, evaluating it, just flip it. Sometimes it could be already a fraction. Let's say you have 1 and 4 to the power negative 2. Again, before you do anything with negative powers, first you want to make them positive. What do you do with this one to make it positive?
Switch.
Try switch it or move it up to the other side. Just move to the other side of the fraction, so it becomes 4 to the power positive 2 instead of negative 2. And this one moves down, so this turns into basically just 16. 16 over 1 or 16. Okay, so whenever you see a negative power, it's simple. Just move that power to the other side, it turns positive, then you apply whatever we learned earlier here to it. What if we have two fractions that both are negative? Two powers, let's say something like this. Negative maybe 3. Not some, let me actually rewrite this. Let's say we have 3 to the power negative 2 and no, 5 to the power, let's say negative 1. Looks like both are negative, but we need to make them positive first. How do you do that?
5 negative 1 over 3 negative 2.
Why the negative? So we want to make them positive, right? So,
Oh yeah.
And
Yeah.
okay, so this moves down to turn positive, and this one moves up to turn positive. So it'll be 5
over 9
over 3
2
to the second. And of course, this is 5
over 9.
Okay, only move something if it has a negative power. Only move the term or the fraction with a negative power.
Professor, what
Yeah.
if the numeral, the coefficient is negative and the higher power is positive?
Okay, we're gonna look at when the base is negative. Okay, there is another example. We will do that. So now we're looking at negative powers. Right after this, we're gonna talk about negative bases. Here's another example of this before we go to the next thing. So let's say you have 3 to the power negative 2. So 2 to the power 3, but this one has a negative power. So which one do we have? Do we move both or just move one? What do we do?
You would just move the 3 to the negative 2 up, right?
Exactly. So only you need to move this one. Only the term with a negative power or the expression with a negative power moves up to make the power positive. This one is already positive. No need to move it. Do not move this down. The reason we moved this down because it had the negative power. So this stays here. It will be 2 to the third. And if we move this up, it turns into a multiplication. It becomes next to a multiplication next to 2 to the third. Okay, so this stayed here. This moved up. Now we can evaluate these two. Then it's a multiplication between them. So 2 to the third, that's 8. 3 to the second times 3 to the second is 9. And this is, of course, 72, right? So that's basically how you deal with negative powers, okay? They may look a little intimidating or complex, but it's very simple. Just make them positive and they turn into something, regular powers, positive powers that we can evaluate. Now let's see what happens when you have negative bases or negative base. So you have negative 3 to the second and negative 3 to the second. These are two separate problems. Okay, so first always identify the base and the power. Identify the base and the power before you start doing anything. What's the base and what's the power here?
3.
Negative 3.
So the 2 belongs to
3.
And here the 2 belongs to the whole
Negative
thing,
3.
negative 3. So be careful here when you have parentheses or when you don't have them. So here 2 belongs to the 3, but this negative is not part of the base. This negative is by itself. You write it first. So this 2 belongs to 3. So then you expand it. So this is 3 times 3. And again, this negative is by itself. When you don't have parentheses, just bring it over again here. and then just evaluate the rest of the expression, that's 9. But this one is different. We have the power, this whole thing is a base, including the negative because of the parentheses. So when you expand this, you got a times -3 by itself. You're going to repeat the negative also. Here we didn't repeat it because it wasn't part of the base, because we didn't have parentheses. So we're going to say -3 times -3. We use parentheses here, which is +9. As you can see, the answer is different for both of them. So again, if you don't have parentheses, just bring the minus over and expand whatever expression you have. But if you have parentheses, that means the whole thing, whatever is inside the parentheses, could be other numbers or letters, the minus itself. So all this is a base, the base to 2. So when you expand it, you repeat the base as many times as the power. If this was 5, for example, then you would write this 5 times. -3 times -3 times -5 times. Okay? This is a quick example.
Professor, I have a question.
Yeah.
But for the first one where it says -3 with the 2, why do you only put a -3 on the first one, not the second one?
Yeah, so this negative is not part of the base. You write it first, okay? Has nothing to do with the other one. So you just have to write it first and then evaluate the rest of the expression. Okay? But this one here, the negative, is part of the base. That's why I repeated the negative also with this. By the way, we're going to get disconnected. Please rejoin. We have to finish this lecture. We still have a few more rules to learn. Okay, so please rejoin right away. I still haven't taken the attendance, haven't done anything yet. So please rejoin. We're going to finish this first and then show you some things on Blackboard and also show you the homework and everything else. One quick example here. What is -5 to the second? And what is -5 to the second? Two separate problems. What is this one equal to?
25.
The first one is
25.
+25.
That's right. So this one is -5.
And the
times
second is negative.
-5.
The second is negative.
That's right.
Mhm.
The second one, this negative is not part of the problem, not part of the base. Just write it first and evaluate your expression. 5 times 5. Again, bring the negative over, you get 25.
Yeah.
See, the answers are completely different. One is +25, the other one is -25. So remember, if you have parentheses over